let's say we have function polynomial function minus 0.5 x4 plus 3x squared plus 2. How you can use a table of a value to identify key features and sketch the graph of the function. Evaluate the average rate of the change over the interval minus 0 and 2. First of all, here let's see if we are let me take a pen. If we are plugging minus 3 in this function here, minus 3 in fourth is going to be negative 81, is a positive 81, time negative 0.5 is going to be negative 40.05. And just let me take a calculator, maybe we can check this much easy. So 3 in exponent 4 is going to be 81 time 0.5, but this is a negative, is negative 40.5, plus here 3 squared is 9 times 3 is plus 27, and plus 2. So is a negative 11.5. So 11.5. This was going to be. If we are plugging minus 2 here, is going to in negative 2 in a 4 is a 16, times minus 0.5 is negative 8. Negative 8. And here 3 times negative 2 squared is a 4, 3 times 4 is 12, plus 2 is 14, minus 8 is a 6. If we are plugging minus 1 here, is going to be positive 1 times minus 0.5 is a minus 0.5. And plus 3 times minus 1 square is 1, 3 times 1 is 3, plus 2 is 5, minus 0.5 is 4.5. So this was going to be minus 1. If we are plugging 0 here, 0 here, 0 here, so it's going to be 2. But because this function is even function, so it's going to be even and it's going to be symmetric with respect to y-axis. So it means it's going to be the reflection here. So in 1 is going to be 4.5, is 4.5. And in 2 is whatever is here in minus 2 is a 6. And in 3 is a minus 11.5. So those are the points. And this point we are sketching in the graph. But first of all, let's just focus here and let's do a leading coefficient test. So because here the leading coefficient is minus leading coefficient is minus 0.5. It means it's less than 0. Less than 0. And degree n is even. It means on the right side and the left side, the end behavior of the function is going to be negative, is going to be down, both sides. And now we are taking those points. Let's say here is 1, negative 2, and negative 3. Negative 3 is a minus 11 here somewhere, let's say. Let's say it's here somewhere. Minus 2 is a, let's say is a 6 is here somewhere. 4.5 is here, and let's say 2 is here. We are taking approximately those points, and it's going to be the reflection, whatever is here too. And in 3, let's say 3 is here somewhere. And if we are plugging those points now, then we can graph the function very easy. So the graph of the function is going to look something similar this way. So this function was easy, but sometimes we have some function, for example, when the intercepts are in a small interval between minus 3 and minus 2, for example, and if we are taking the table, it doesn't help us to draw it. But sometimes it helps us, for example, if those intercepts are in points very far away one from another, like this one, for example, between minus infinity and 0, here somewhere. So if they are very far, but if they are very, very near, it's very hard, to sketch out the graph properly. So now if we are looking to evaluate the average rate is, let me write average rate here, is equal to the f of b minus f of a. But f of b here is 0. This is b, this is a. Is f of 0 minus f of negative 2, divided by b minus a, which b is a 0, is a minus 2. We already see here we have those values. F of 0, what is f of 0? F of 0 is 2. Okay? F of 0 is 2. And here is 0. Negative times negative is positive, and 0 plus 2 is 2. So let me write down. Here is a negative. And f of minus 2 is 6, positive 6. And it's going to be minus 6 plus 2 is a minus 4 divided by 2, which is a minus 2. So the average rate is minus 2. From minus 2 to 0, from this interval to this interval, the average rate is minus 2. So this average rate is a minus 2. So just let me write average rate is minus 2 in the interval from minus 2 to 0. So, and it makes sense because it decreases, it goes down.